the properties of engineered aluminothermic materials. So of course people are familiar with thermite, which is a mixture of powdered iron oxide or oxide of another metal and aluminum in the metallic elemental form. So aluminum is a very reactive metal, but of course we have aluminum everywhere. But the reason it's not reactive, it doesn't react automatically with things normally, is because it's what's called passivated. It has a thin layer of oxides, atoms on the outside, or molecules on the outside of the surface of it that prevents it from reacting. What happens when thermite reacts is that the energy of the reaction, the heat of the reaction, overcomes that, and the iron oxide starts to react with the aluminum, so you get this extremely exothermic reaction. That's why thermite is so hot, burns so hot and so bright. It's extremely exothermic, but it doesn't burn particularly fast. It doesn't react particularly fast unless the particle size is reduced to a size where to a size that increases the rate to a corresponding rate, because it's all about the surface area. The smaller the size of the particle, the faster the rate of reaction. And the rate of reaction in these engineered materials, these engineered aluminothermic materials, such as they discovered in the World Trade Center dust, is that they also have this matrix that mechanically embeds the particles of aluminum and iron oxide, and has other elements in it that themselves probably contribute greatly to the gas pressure when it reacts, so that thereby probably giving it a detonation behavior, where if it experiences a high enough energetic pulse, even if it's a microscopic one, it will generate this blast wave that will rip through it and instant, at the speed of maybe 10 times the speed of sound and air, this blast wave will travel through it and create this intense pressure wave. It's just like a high explosive. So so we believe that this stuff in the dust has this high explosive property. This thing that I think was really important to figure out was that this material almost certainly has at least two types of behavior, two modes through which it can react: a slow mode and a fast mode. So the slow mode is probably what they're seeing when they heat the stuff up to 430 degrees C in the differential scanning calorimeter that precisely measures the amount of heat going into and out of the sample. And when they get it up to 430 C or about 400 C thereabouts, the reaction takes off and it gets so hot it goes above the melting point of iron, as can be seen by looking at the residue of this reaction, little molten, previously molten spheroids of mostly iron. So it experiences that thermitic reaction, but in order for it to do it at a high rate of speed, it probably needs to be subjected to an extremely high energy event, like a little spark or a little pressure, something such as would be provided by a micro detonator, of which there's you can find out a lot just by searching, try Googling a micro detonator or nano detonator or something like that. There's all kinds of research in ways of making these little tiny detonators, such as I think were probably used at the World Trade Center. I imagine that they had just massive amounts of this material in the buildings. I mean, that's one of the really kind of surprising, well, it might seem surprising, is the estimates of the total amount of this material in the buildings is on the order of tens of tons or even hundreds of tons, which is a fantastic amount of material. But and that makes prompts one to ask, well, how did they install it? How could it have been depended on to reliably detonate when they wanted it to? Well, if it had this bimodal behavior where it would deflagrate if it experiences anything other than the extremely sudden onset of this high energy burst that's required to detonate it, it will simply deflagrate. It will look it'll just blend in with an office fire. I mean, it might increase the office fire. Maybe that's why the fires in the North Tower seemed as vigorous as they did. I mean, there's entire floors you can see were on fire in the North Tower. And maybe if, as I've suggested in my essay, Hypothetical Blasting Scenario, the method of installing so much explosive material was to embed it in some innocent-looking building component, such as a ceiling tile, and have virtually every ceiling tile on maybe every other floor in the building retrofitted with these high explosive thin sheet high explosives that will only explode with high brisance if they are triggered by their built-in wireless detonators. So it's to me it's all very conceivable how this all could have been done as kind of a mass production operation in building building components that look completely innocent, that could have been swapped in as part of a normal building maintenance operation. Ceiling tiles getting exchanged. What could be less conspicuous than that? So what I was describing is this idea of, it's always I've always been trying to account for how there was such a thorough pattern of destruction in the tenant spaces in particular. 1,000 bodies, not even a single fingernail size remnant of more than 1,000 bodies was ever recovered in order to identify so many people, so many bodies. If you look through the rubble of Ground Zero, I have looked through hundreds of pictures of Ground Zero, every one I can find, and I have yet to find a single one that shows those very distinctive web trusses. Just a fragment, just a few feet of just like 4 feet or 10 feet of a web truss that you can see that zigzag rebar pattern, that very distinctive shape of a web truss. You just can't find it in the rubble. All you can see is just twisted rebar. It's like and not to mention the floor decking. You can see a few pieces of that what looked like that corrugated floor decking, but no more than like a couple feet long. 1 foot by 2 feet. And then not to mention the concrete that was just so thoroughly pulverized. Just most of it was apparently just turned into fine powder. If they were really high brisance explosives, it's planar blast waves that would attenuate very little as they moved up and down through that floor space and hit the floor above and the floor below, because they're it's like a parallel wave. Very little attenuation, and yet when it starts to get outside of the building, it attenuates very rapidly because of the angle that it's at, and not to mention the perimeter walls, greatly attenuating it. So providing a very uniform and high pressure blast wave inside the tenant spaces. So that's one component of this blasting scenario, and that's where I think this the stuff that they've discovered in the dust, the red great ships, are part of this material that was embedded, perhaps in the ceiling tiles or whatever. But in addition to that, there's obviously more going on in destroying the building than this really high explosives action that you see happening when the building starts to come down. That's what I think these thin explosive film, these sheets of explosives that were in the ceiling tiles, if that's what it was, were. Before that, of course, there's evidence of a direct attack on certain parts of the steelwork that's revealed in this highly corroded steelwork that you see. It's like been vaporized down to a thin scrolled sheets of pieces of steel, and that the orange spout that emerges from the south tower just seconds before the tower comes down looks very much like a conventional thermite reaction, where you have molten orange steel, or rather iron pouring out, and a white iron oxide aerosol rising up. This just looks exactly like thermite. And so that suggests to me, along with the other evidence of more conventional aluminothermic incendiaries, that the first stage of the attack, there's like basically like kind of a two-stage attack. The first stage was to attack key parts of the steelwork with incendiaries. Incendiaries in a lot of the same places that the fires were, like right around the crash zone, to actually blend in kind of with the damage caused by the crashes, and actually get the whole center to turn into this giant cantilever. If they attacked all the columns, say around the crash zone, the entire upper block, if they allowed the core to go of the entire upper block to go into eliminated its support, it would act like this incredible, very high leverage weight that would pull in the perimeter walls and do just what NIST says the fires did, which was to pull in the exterior walls, because that's what you do see happening, especially in the beginning of the onset of the south tower destruction, is the wall actually pulls in. It's kind of an implosive action initially, and then right after that you start to see all the explosive action. That's when it appears that the high explosives start up. So by strategically weakening the buildings with I would think perhaps something like a thermate coating that was like a compound that looked just like fire retardant paint. Just, again, an application procedure that was
innocuous.
looked like a normal, innocuous, or even one that was supposed to protect the buildings against incendiaries, were actually, or against fires, were themselves incendiary.